Alan Ryder, Southeastern Railway Museum, and it's been a little while since I did some work on locomotives. For most of the summer I've been working on our inspection pit and thought I'd take a break and get caught up on a few things. Before we do that, thought I'd give you an update on our E8 project, 6901. So after about 810 man-hours worth of volunteer labor, we've got the old girl ready for our contractors to come in and give us a paint job. So you can see where we've replaced metal here, and walking down the side of the locomotive, there's all sorts of places where we've repaired batten strips or replaced side panels. Over here, these are a couple of the side panels that we took off that were rusted out. And you can see them here, the new ones, the whole batten strips and all that other good stuff. Walk around on the other side. More replaced side panels. And a piece of the skin that was rusted out that we had to replace. So she's pretty much ready for paint. This is former Georgia Road 1026. It's a GP7, and we've had it for a long time. We use it a lot for switching, and it's got a little problem. Crew's reporting that it's not loading, which means it won't move itself. So we need to investigate that and see what's going on. We've had some reports of some loading problems with 1026 here, and this is the isolation switch. And from what we're gathering, there's a problem with the contacts on the isolation switch. This is the back of the isolation switch, so what I'm going to do is to clean those contacts. I brought a point file and I brought some sandpaper, so we're going to clean those up and see what happens. It's hard to see in video at the same time, but I've got a point file right here stuck between the contacts, so I'll file it like that. I've got the switch closed, and we'll do that on all 8 or 10 of them or whatever they are, and that should do it. We'll see. So I finished this up with a piece of sandpaper wrapped around the file. You can see it kind of sort of there. Better view with the file and the sandpaper. And I'll spray it with some electrical cleaner, and then we'll fire this engine up and see what happens. Okay, well, we got the isolation switch all cleaned up, and that wasn't the total problem. It turns out the locomotive is loading in one direction but not the other. And what you're looking at in the electrical cabinet is the reverser. This is the device that connects the traction motors for forward or reverse direction. So you can see all the contacts here, and if I push this magic button, it's operated pneumatically. These are the magnet valves, so if I push this one, it moves over. If I push this one, it switches the other way. So what's your problem? Well, the problem is, which is a little hard to see because it's not well lit here, but you see those wires on that magnet valve? That's the reverse direction magnet valve. And if you look at this magnet valve, as best I can get the light, there are the wires. They're not supposed to be loose, they're supposed to be on the magnet valve. So the by vibration or whatever, the wires that are connected to the coil of that magnet valve have broken and fallen off. So we're going to have to take that magnet valve off and find a replacement. So what I'm going to do now is there's nothing wrong with the magnet valve, it's only the coil. So I'm going to take the coil out, and hopefully this camera will do it. Now we take the wires off. Because I need this. This is the terminal that actually goes on the coil. Nothing like having the sockets be two different sizes, or the nuts on one side versus the other. Well, we'll get it. So now we have all the parts, so we're going to take it home and see what we can do to fix it. So here's the magnet valve coil, and I figured out how to repair it. First, these are the terminals that the wires connect to. This is one of them, and that's another one. And the coil wires, and there's like the thousands of turns of wire inside this coil, are soldered to these little terminals. And so what I've done is I fixed this one. I think it's this one. It's hard to see through the viewfinder. Basically I scraped the insulation off of the wire. You can kind of see that's a bit shiny there, and twisted the wires together and soldered it. Fortunately they had enough lead there that I was able to do that, and once I get that done, then I'll put some of this is insulating fiber material. That's what is between the wires and the coil. And you know, basically what happened that caused this to fail is this stuff got brittle, and there's actually quite a bit more of it that fell off and didn't hold these terminals in place. So in vibration they just kind of came loose with the weight of the wire and broke loose. You know, these coil wires are very, very fine. So I'm going to try to show you how I soldered this back together. Not sure how well it's going to turn out, but first I'll twist these really fine wires together as best I can. Here, soldered back together. Now all I have to do is to figure out how I'm going to secure these terminals back to the coil so they don't break off again. So I decided to use a technology not available when this coil was manufactured in the 1940s or something like that, and that is good old double stick tape. So I've got the terminals secured with the double stick tape, and that'll be just the first layer. I will use probably some sort of glue to secure the wires and make sure they're insulated. They should be okay now, but I want to make certain. But before I go any further, I want to be sure that we got good continuity through the coil and my soldering joints worked. So pulled out my good old Simpson 260 meter. As far as I'm concerned, the best meter ever made. And as you can see, we've got a resistance reading, and it's about what it ought to be. So I've added a bit of epoxy here and there to secure the wires and secure some of the insulating material. Now the next step is I'm going to wrap string around the coil to hold the lugs in place, and I'm going to do that off camera because I'm also going to be using a little bit of that epoxy to hold it down, and epoxy and cameras probably aren't going to mix real well. That should do it for now. After the epoxy cures, my plan is to take this and paint it with varnish, and that will seal all the wraps of twine in place and pretty much glue everything down, and then after that dries it should be ready to put back on the locomotive. Almost as good as new. So I've got the coil mounted on a bolt on the vise so that I can turn it back and forth to get it in position where I want it. And now got a can here of varnish I've had forever, so we'll give it some paint. Well, that about does it. Got a coat of varnish all the way around. Now it's just a matter of waiting for it to dry and see what it looks like. Maybe we'll put another coat on, maybe not, just depends. One coat was plenty good, and now the next day we're back on the locomotive. Coil installed and wired up. Now just put the top back on. Top on. Now all we got to do is start the locomotive and see if it works. Looks like we got it fixed this time. Throw the reverser forward. Open the throttle. Watch the load meter. Throw the reverser the other way. Looks like all's good. Well, we got her all fixed up and ready for another day, loading in both directions. So that's going to wrap this video up. And as always, thanks a lot for watching, and come see us sometime.